We treat the calendar as a static, objective truth. It is the foundational ledger of human history, a continuous record that accounts for every year, month, and day between the ancient world and the present. However, a specific mathematical anomaly suggests this ledger is inaccurate. The hypothesis claims the current year is a fabrication, and our timeline contains 3 centuries that never actually occurred. If the underlying chronological data is broken, then every historical event we use to orient ourselves is floating on a disconnected timeline. Our sense of the present relies on a sequence that may have been systematically altered. This chart documents modern timekeeping mechanics. In the 1980s, historian Heribert Illig investigated the transition from the Julian to the Gregorian calendar. He identified a discrepancy in their alignment with astronomical cycles. The math reveals an unaccounted gap of 297 years. This gap overlaps with a period between 614 and 911 AD, an era curiously devoid of significant architectural development or archaeological artifacts. The physical record for these 3 centuries is remarkably thin. When the mathematical errors in the calendar align with the missing layers in the Earth, the result is a distinct chronological void. Human history has a documented blank space that defies standard explanation. Historians interpret this void as manual forgery. They suggest medieval scribes intentionally rewrote historical documents to insert fake years. Forging a longer history allowed rulers to claim a more ancient, legitimate right to power. This perspective treats the missing years as a localized human deception, a successful attempt to hack the physical archives of the past. We can also view this gap through the lens of information theory. If history is essentially a collection of stored data, then a missing era functions less like a lie and more like a file corruption. Computational systems in simulation theory are vulnerable to catastrophic data loss. If the environment fails to render a block of time, that information is deleted. A system crash explains the missing data, leaving a digital scar where 297 years belonged. This framework classifies the phantom time anomaly as a hardware failure in the fabric of reality. When a digital system encounters a gap in its data, it often uses procedural generation to fill the space. This prevents the entire program from shutting down by creating generic, low-detail content to bridge the break. The Dark Ages possess the exact characteristics of a software patch. The era is historically vague and lacks the high-resolution cultural data found in the Roman period or the later Middle Ages. A system in recovery would prioritize stability over detail. Generating a few centuries of stagnant, localized history requires far less processing power than simulating a complex global empire. The early Middle Ages function as a procedural bridge, a low-resolution illusion designed to hide a 300-year rendering error in the timeline. The phantom time hypothesis forces us to confront the fragility of our historical consensus. We rely on a chain of events that is only as strong as the ledger it is recorded on. Both theories conclude that our history is not a continuous line, but a fragmented sequence spliced back together. We seek physical evidence to anchor ourselves in time, yet those very anchors, from stone calendars to ancient manuscripts, are what these anomalies call into question. Our focus on modern events often distracts from the possibility that a significant gap exists in our deep past. The 300 years of missing code provides a diagnostic for a simulated reality. If the timeline is broken, then the world we are living in is not the one we were told to expect.